Hi, I'm Pumphrey.
I'm Company.
And we're Pumphrey & Company.
Here we restore collector cars from the antique and classic era as well as European sports cars.
We'll be producing videos on both historical facts on automobiles as well as technical things from machining, sheet metal work, fabrication. We'll produce more of the one that you like as long as you give us some feedback. If you like it, subscribe.
If you really like it, tell your friends.
Okay guys, so today we're going to be making these. This is a machine piece. Here I've already made some. They have a screw here and a screw on the top here. And what they do, move this bag on out of the way here. They seal the cylinder down there. Let me make sure you can see it here, but you can see I've already machined the seats. And so they have a little copper crush gasket on there, like so. And it goes up on the cylinder, and that's basically your head gasket. Now, the originals are a bunch of different materials. You got cast iron. This piece is kind of brazed on there. It's broken or something. And somebody brazed this on here with that. I didn't understand the whole idea, so I'm just going to make solid ones out of a high steel or a high strength cast iron. So we'll go through the processes of making this. See the step there. And you'll see how it looks. This goes in here. The top of the block. You can see after we've kind of had to piece this all together here, it seals the plug here, and then the water manifold goes on top. So when we say that we make pieces or we make these cars, we actually physically make the parts. So let's get to it. So anybody doing this at home or as a hobby or something, you can simply start out with making a quick diagram of what you need to make. And the important thing here is you need to think of, as a machinist, what processes it takes to make that piece. It's not simply just chucking it up and then hitting a program go. You have to think about how you're going to hold the piece. It's not light. It's got to sit hanging out that chuck, and you got to make some big heavy cuts, because otherwise you're going to be there all day. So here we're first going to take it, chuck it in, and I machine it smooth so I can chuck it into the vise, or into the chuck, well. And then we're just going to mark off what we need to do, cut all this to a 1/2 inch, then come in, clean it up to these sizes, cut our groove here, and then thread them. So it doesn't have to be on a computer. It can be quick, be on it by hand, and let's do it. Okay, so in making this piece, we've made our two, basically our hogging passes. Now we'll come in for a final pass, and we're going to clean this up, taking off about 14 thousandths. The reason you do that is that when you're taking those big cuts that I was taking, the piece is going to deflect and bend. There's nothing there's nothing you can do about it. It's going to deflect and bend. So you hog it out. We made 2 passes and cleared, well, that much material. And then we're going to come back, and then you make your final pass just to clean it up. So I'm going to take about a 14 thousandths cut, and here we go. Okay, now we've hogged this down and we're ready to thread. So first thing we're going to do is grab my threading cutter, my thread tool. I guess I'm going blank on the name of it here. But you grind this at 60 degrees plus or minus the helix angle. So then you make sure that the cutter is square to your piece you're going to cut. Now you don't just feed this in at 90 degrees. You do at the very end, or at least I do, because it's more of a form tool in this configuration. But you also use the post you set up at about 29 degrees. You do this depending on the thread and depending on how you want to cut. So we go down here. We know that we're doing 3/8/16, so we make sure that this is set up to 16 threads per inch. There it is. We make sure that the lead screw is engaged. So the difference here is, when I'm powering through and I'm taking big cuts, the power is through this shaft. And then it goes through a set of clutches and everything in this. A tool room lathe has to be very precise, and it has to keep that precision. So the threading lead screw is only used when you're actually threading, so you can see the cut here. And that's the precise piece. Now on this one, you'll also see that I engage it here once, and then I can use the rest of it, and the machine will automatically back out at the end of the cut, and then I'll walk it over, and then we make our next cut. So this is never disengaged, and it never gets changed. It's also it's faster that way. So, any questions on threading, ask them. I'd be happy to answer them. Let's start cutting. Okay, now we're on to the big piece. Let's cut this one. Okay, now we're on to our last, or second to last operation, which is facing it. So we lock the carriage here, we walk it in, excuse me, then we lock the carriage, and then we go in and we take our first cut, and that establishes our 0. So that's as simple as just turning it and getting a couple thousandths off to establish 0. And then we are going to measure the thickness here, and we just simply machine it down. Pretty simple, let's do it. Well, there we have it. We're all done. You take something, you divide it down into the different processes, and what starts out as being real complicated turns out not to be that difficult. Of course, on this, it looks like it's done in 2 seconds, but anyways, hope you enjoyed. See ya.